Hello everyone, it's Yaman from the tech team. In this video we're going to learn how to add reactivity to the universal profile using LSP1 Universal Receiver standard. So let's go through the universal receiver and know more about the problem that this standard solves. We're gonna do that by taking an example of an ERC20 token since it's the most used currently in the space. During an ERC20 token transfer, the sender will call the transfer function on the ERC20 token, and then this token contract will just decrease the balance of the sender and increase the balance of the recipient without further interaction. The recipient will be totally excluded from the interaction regardless if it's an externally owned account or a smart contract. So this recipient cannot know which token it owns. And even in other standard where a function on the recipient is defined, the notification is limited and designed in a bad way. So for instance, ERC 721, 1155, and 223 define functions to be available in the recipient contract to accomplish a successful safe transfer. So let's say, as a recipient, my contract is deployed, and 2 years down the road, a new NFT standard gets adopted. My contract will not have the ability to receive these kind of tokens because it won't be implementing the mapped ERC XXX received function. Other than that, these functions are not mandatory to be called. These will be called only on safe transfer. And also, the standard does not define an event to be emitted on the recipient. So, off-chain clients cannot easily filter what tokens you own as a recipient. They would need to query the whole blockchain and token contract to know what token you own. So this shows that this way of notifying is broken and we need to find a better way, and this is possible with the universal receiver function that we standardized in LSP1. So LSP1 defines a function called universal receiver, and the whole point of this function is to emit an event to the network with the data passed to it. So let's say you inform a smart contract about a specific message. An event will be emitted with who's informing, which is the sender, how much value he's sending, what type of message he's sending, and the additional data attached to it, and the response of the universal receiver function. Not just that, this function can allow you to react on the call. So for instance, you can specify in the function that whenever a specific entity sends you a token, half of this token will be sent to a vault you own, or distributed equally to other recipient addresses. The standard also takes modularity into consideration, so it's not recommended to hard code a specific logic within the universal receiver function, but rather delegate the responsibility of reacting to an external contract called the universal receiver delegate. And this is because you might need to change how you react on specific call. So now you can decide to split all the token you receive 50-50 between you and the secret vault, or later you might want to disallow anyone from sending you a token, or filter the spam token and only allow whitelisted token. So universal receiver implement the universal profile, implement the universal receiver function, and as you can see here, you can have your tokens inform the sender and inform the recipient about the transfer. In this way, not just you'll get notified, but also you can react on the token transfer. As shown on the screen, the universal receiver delegate can contain any logic from rejecting the transfer, forwarding the asset to a vault or a staking pool, etc. So in a previous video, we explained why there is a need to have LSP17 contract extensions within the universal profile and how you can add them. However, it's important to differentiate between notifying the universal profile using universal receiver and calling an extension on the universal profile. When a token will notify you, the events will be emitted on your profile. In this way, if I need to know what tokens or followers or whatever people decide to notify about, you can just listen to the universal receiver event emitted on the profile address. However, with LSP17 contract extension, websites need to fetch what extension you previously had from the events and then fetch the events from these extensions gathered, so this will be much slower and unreliable. Plus, the universal receiver is inclusive, meaning that by default you'll not reject any call to inform you unless you decide to. However, with the extension, if someone is informing you by calling the extension that you did not add yet, the call will fail. So it's all about having more flexibility and knowing where is the right place to perform certain actions. LSP17 contract extension are to extend the functionality of the universal profile, and universal receiver is to inform you about incoming transaction and you being able to react on them. And with that being said, let's see a demo on how to use the universal receiver and how to add universal receiver delegates. So I created a new hardhat project. You can do that by installing hardhat. So you'll do npm install hardhat, and then you'll do npx hardhat init, where you initiate a new hardhat project. So I created a TypeScript project. Feel free to do that with JavaScript if it's easier for you. These are the packages that I'm using, so you need to install the LSP Smart Contract package. By doing that, I use Prettier and .env to have the environment variables, and this package will be automatically installed with hardhat. So for the samples of the environment variables, you'll need to add the private key of your browser extension controller. So there will be other tutorials that show how to extract the private key from the browser extension, and here you would put the address. So obviously you need to put that in the .env, not in the sample. This is just to show you how to do it. So we're gonna start by looking at the main setup that I created. We have here, we're importing ethers from hardhat. We are taking the universal profile API from the LSP Smart Contract package, and we're instantiating a new instance of the universal profile by passing the universal profile address, the API, and the provider which connect us to the Luxo testnet. So we can run this script to see our addresses. So we'll do main setup. And we can see here, this is the address of the browser extension controller, and this is the address of our universal profile. So in this specific tutorial, we're gonna call the universal receiver function, and we're gonna watch the events emitted. And we're gonna say why this is useful. So first, let's start by adding a listener to the universal receiver event. So we're gonna create this, and we're gonna do universal profile on, and we're gonna listen to the universal receiver. So obviously there's different parameter with that. There's the from, who's calling the universal receiver, the value he's sending, the type ID, which is a unique identifier about the action that the person is calling to notify about. There's the received data, additional data that you want to notify about, and then we can just say the universal receiver event was emitted. You can say the universal receiver was called by from passing this amount as value to notify about this type ID with these data. So what we can do is run this script. We can run this script here and go create a new terminal, and within our main setup we're gonna try to call the universal receiver function and see if the event will be emitted. So obviously events take some time to be detected, but let's see if it's gonna be super slow. So what we're gonna do is that we're gonna call the universal receiver function on the profile. So the universal receiver function take two parameters, the type ID and data. So the type ID represent a specific action that you want to notify about. So it should be like a unique identifier for the action that you want to notify about. So we can say that we want to notify about a royalty. So we create the hash of the word royalty, and this will be our unique identifier. And then as data we can pass whatever we want, like the address, or like royalty about like which token contract or about which product you're selling. So but for now we're just gonna use this dummy data, and then we're gonna wrap that in a transaction. So let's run this transaction. And obviously, even if you didn't touch your universal receiver function before, the transaction will pass, because we said that the universal receiver function is inclusive, meaning whenever you deploy your universal profile, you don't need to do any setup. If someone calls this universal receiver function, the transaction will pass, because it's just emitting an event and it's searching for universal receiver delegates to react on the notification. But if you didn't set any universal receiver delegate, we should expect it to pass. So if we go to the other terminal and wait for a bit, we can see that the event was emitted. So maybe not this one. Here we can see that the universal receiver was called by OXE4, which is the signer, because we have seen that whenever I log the signer, it's this one, passing 0 value, we didn't send any, to notify about, which is the hash of the word royalty, and with ABVCDD as data. So what we can do is pass some data here and see if it changed. You can see we're sending 10 way, and then we run the script again. And we wait a bit till it's mined on the blockchain. And we go and we can see that now it's updated with 10 value. And even this not just can be done with externally owned account by calling the universal receiver. So you can have a token. So let's say we're creating my token, which is first let's import LSP7 digital asset from So there would be other tutorials that show you how to deploy and create an LSP7 digital asset. For now, we're just gonna use it as a sample to see that a token would notify you about the token transfer. So the LSP7 digital asset, we need to pass some arguments, like we need to pass the name of the token, the symbol. We need to pass the owner, which is, let's say, message.sender, and then whether it's divisible or not. For now, it's not very important. And I'm gonna create a function that's called mint and takes a recipient, and it's called by anyone just for the sake of the demo. So the amount will be 10, the recipient be this, let's set to true, and as data I just want to pass 0x, or let's keep it empty. And now I'll just compile the contract. And I would need to deploy, so I'll just go here, take this and deploy the contract. So I need to import and I take the factory, and the signer will deploy this one. And what we're gonna do is that directly we're gonna mint some tokens. So this is the signer, gonna mint, and we're gonna put the universal profile address. So this, then so we don't need this line, and let's run this script, which is deploying contract. So what did did I do as a mistake? Probably. Yep. So we're waiting till the contract is deployed, and we're minting some tokens to the universal profile, which is supposed to notify also the universal profile. So hopefully we can see that reflect on the events that we're listening to. So let's wait, so it's deployed. So now after fixing the code, I just needed to add a gas limit for some reason. So I added a gas limit and it went through, it didn't revert. So we can see here that it didn't revert. And hopefully whenever I minted this token to the universal profile, it should notify the universal profile, and we're gonna see if it did notify or not. So we're gonna go here and we see that it actually notified. So now the universal receiver was called by this address. We see that it's a different, now not the signer is calling the universal receiver, because actually the signer is calling the mint function and the token contract is notifying the universal profile about the transfer. So this is the address of the token contract, and we see that it notified with 0 value because it's not sending a native token. It's just the token that we created about this specific type ID. So if you go to the LSP7 spec, you see that this type ID is to represent that you're receiving an LSP7 token. So now even you can say that you want to filter the universal receiver event with this type ID, and this way you'll just get the notification when you receive an LSP7 token. And these obviously are the data associated with the transfer that you can choose from the token contract. So the whole idea of notifying and listening to the event of the universal receiver is to say that now we don't need to index the whole blockchain anymore and check where is the transaction where my address is associated with. Now we can just listen to the universal receiver event and know what are we being notified about, or what we're receiving. Is it like a token, follower, a royalty, anything. So now let's see how we can use the universal receiver delegate. So we'll stick to the example of the token. So we have this LSP7 digital asset token, and whenever we're minting or transferring a token to a recipient, this recipient, if it's a universal profile, then the universal receiver of function of this universal profile will be called with specific parameters that we're gonna see now. So if we go to the LSP7 specification, we can see if we go to the transfer function, which applies the same to the mint function, we can see that if the token recipient is a contract that supports the LSP1 interface, which is the case in the universal profile, it should call the token's recipient universal receiver function with the parameter below. So this is the type ID that the universal profile will be notified with. So we're gonna take it, and for now let's just put it here. So we can create a logic in our universal receiver delegate that depend on this type ID. So for instance, in this tutorial, let's take a simple example, which is allowing just whitelisted token to be received. So what we're gonna do is that we're gonna create the universal receiver function, universal receiver delegate. In the case of a universal receiver delegate, it should take this form. The sender will be the person notifying the original universal receiver function, value how much he sent, the type ID which is passed, and the data is passed. So we can just do that, and then returns bytes. So this needs to be added with the types. So now we have it. So now we can say if the type ID is equal to this one, which signal that we're receiving an LSP7 token, we need to first add a mapping that will hold the logic of whitelisting. So address, then boolean public token, the bool, the status. And for simplicity, we're not going to add any modifier now, but this should be only callable by the universal profile, so he can control which token to allow or not. But for now, let's just keep it simple and just do that. So we're gonna say that require that the sender, which is the person notifying the universal receiver function, so we're gonna require that the sender is whitelisted. If he's not whitelisted, it's gonna revert. So let's compile. Obviously we're gonna ignore the rest. We don't need the value or the data, so it's not necessary that we use them. It's just we use what we need. So we're gonna do that, and then we're gonna compile. And an important thing that I just forgot is the support of the LSP1 delegate interface. If we don't support this interface ID, then this function will not run. So obviously we need to do support interface, which bytes 4. So this is a critical aspect to the universal receiver delegate, and we say, since we're importing, we can just take the interface ID from here. And now we can compile, and this should be working. So now we're just compiling and compiled successfully. Now we need to deploy this universal receiver delegate and add it to the universal profile. So now let's take the universal receiver delegate factory. Actually, let's keep both so we can deploy a new token. So we deployed a new token. Let's remove the logic of, so this is my token.target, and then we're gonna deploy the universal receiver delegate. And we're gonna emit. So let's do that. Let's also set a gas limit so we don't fall. So this gas limit is a bit exaggerated. But it will work. So npx hard run script. Deploying contracts. It might take a bit of time because so the first one is the address of, we're gonna put it here somewhere. This is the address of the token, and this is the address of the universal receiver delegate. Cool. So now the step would be to first check if we mint some tokens to the universal profile, it will not fail because we didn't set the universal receiver delegate yet. So what we can do is just, so we need to instantiate the token contract. So let's do that. Let's do, we take the address of the token from here, we just put it here, and the API, so I created a function called mint with address. So it's very simple, you don't need to make it complicated. And now we would just call the mint function to the universal profile, and hopefully it should go through. wait a bit. And it should be working because it didn't revert. So it didn't revert, obviously that means it's working and it minted some token. But now what we're gonna do is that we're gonna add this universal receiver delegate, which will revert whenever we send the token because it's not whitelisted yet. So what we're gonna do is first we need to construct the data key of the universal receiver delegate. So currently the universal profiles deployed by Luxo will have a universal receiver delegate that will be responsible of writing the address of the assets you receive and the vaults that you receive. And this is a common behavior that everyone agreed to, but anyone can change this universal receiver delegate. But now we're not going to mess this setup, and we're just going to add this as an extra universal receiver delegate just related to the type ID of receiving LSP7 token. So we're going to do that. We're going to start by constructing the data key. So we're going to say we need to import the ERC725Y data key from the Luxo package. We're going to construct, so the type ID, we put it right there, I guess. So this is the type ID, we're going to need it. Type ID of LSP7 recipient. Constructed data key equal. And then we're going to use the LSP1 universal receiver delegate prefix, which is 12 bytes. And then we're going to concatenate that with the type ID. So we'll need to remove the first 2 bytes and then take 20 bytes. So it will be 2 to 42, and then this will be a bytes 32 data key. And then the address will obviously be the address of the universal receiver delegate. So what we're going to do is we're going to create a transaction that call set data on the universal profile. So if you're doing that with the universal profile deployed by Luxo, you need to make sure that the address of the universal profile browser extension, the browser extension controller has the permission of add universal receiver delegate or edit universal receiver delegate if you're going to remove one and replace it with this one. So there will be other tutorials that show how to give the universal receiver delegate permission, or like how to edit it from the extension or programmatically. So I'm not going to do it in this one. So I just do constructed data key and then the address of the universal receiver delegate. And then we're going to wait till receiver delegate. So let's see whether it goes through or not. So it went through, so we assume that we added our universal receiver delegate, and we're gonna make sure if it's working or not. So now what we're gonna do is that we're gonna try to mint some tokens to the universal profile and see if it's reverting or not. We do, so we just put them in the deploying contract. It's not accurate, but just put the code too. So after waiting for a bit, the transaction went through and it actually reverted. So we can see transaction execution reverted. And here's me trying again to run the script, and it actually reverted. And this is because our universal receiver delegate is now reverting on non-whitelisted token. So what we're gonna do is that we're gonna go to what we're gonna do is now we're gonna whitelist the token that we have. In order to do that, we need to interact with the universal receiver delegate contract. So also we're gonna do that from the same contract. So we just first load the API, so we need to see what did we name the function, like this, and then we do instant API. Okay, and then we just instantiate my universal receiver delegate contract. We have the address of the universal receiver delegate here. Then this is the API and the provider, and we just do proceed with connecting with the signer, and then we're gonna call the function. So we're gonna say change whitelisting. So first we need the address of the token so we can whitelist it. We already have it saved here, and then we're gonna say true, so it means that it's whitelisted, and then we're gonna wait till the transaction is mined. So just in case, I'm gonna add a gas limit, or maybe not. Let's see if it goes through. And we wait a bit till the transaction is mined. And now the transaction is mined, and we know that we whitelisted the token, so now we try again, and this time the transaction need to go through. And for that, to make sure that it went through, I will be listening here to the universal receiver event. So I'm gonna run this script, I'm gonna run it here, and now I'm gonna proceed with minting a token to see if it's gonna notify and if it's gonna pass through or not. Let's see. So we wait a bit, and we see that it didn't revert. So this is the first sign that our universal receiver delegate worked, because earlier it reverted when we did a mint. And now when we go to the universal receiver event, we see that this is the address, actual address of the token. So we can compare it. You can see that this is the address of the token, which means it minted some token and notify about this one, which is the type ID that we already set a universal receiver delegate for it to react on it, and we have some other information that is passed by the token contract. So that shows that we can add any logic to the universal receiver delegate and make it run on whatever action we decide to. So that needs standardization. In LSP7 we did it, so we can see here that we standardize the notification for receiving token and for sending them, and in this way you can react on them. So this example was a bit simple. If you need to go through more advanced example, you can go to our docs. You can see here in the guides section, create a universal receiver delegate, and this one is a bit advanced, so you can see how you can split the LSP7 token, like transfer a percentage to another recipient, which is a bit more advanced than just whitelisting. So that's the guide for today, and if you need to check the code, this will be all organized under this GitHub repository. Thank you.